Hello students, a very happy morning to all of you. Welcome to Science Online Learning. Today we are going to discuss about two important topics in this video. Students, do you remember what did we learn in our previous video? Yes, we studied about matter, the three states of matter. We also discussed what causes a difference in states and also about the general properties of solids, liquids and gases. Before starting up, let's quickly revise what we have learned in our previous class. The general properties of solids. A solid has a fixed shape and a fixed volume. Solids cannot be compressed. This is because the intermolecular space in solids is very less or negligible. So that is why the molecules cannot be pushed further closer, and solids does not flow because the molecules are so tightly packed that they cannot slip over one another, and the solid expands or contracts very little on being heated or cooled. Next, we learned about the general properties of liquids. So what are the properties of liquids? A liquid has no fixed shape. It takes the shape of the container into which it is poured. And a liquid can be compressed only to a small extent. So this is because the intermolecular space in liquids is not very large. So the molecules can be pushed closer only to some extent. Then a liquid can flow because the intermolecular force being very weak, the molecules can slip over each other. Fourthly, a liquid expands or contracts more than a solid. Lastly, we discussed the general properties of gases. So what are the properties of gases? A gas has neither a fixed shape nor a fixed volume. It assumes the volume and shape of the container. Next, gases can be compressed to a very large extent than solids and liquids because the molecules of gases are very far apart from each other. And next one, gases expands or contracts to a great extent on being heated or cooled. Fourthly, gases freely mix with one another, and this phenomena is known as diffusion. Lastly, a gas moves from a region of higher pressure to the region of lower pressure, and this is the reason why how wind flows from the area of higher to a lower pressure to equalize the pressure in both the zones. Today we are going to learn about two main topics: does molecules remain motionless in matter and the action of heat on matter. First, do molecules remain motionless in matter? So what is meant by motionless? So motion means movement. So motionless means without movement. So do molecules remain motionless in matter? So does molecules remain without moving in matter? The answer is no. The molecules do not remain motionless in matter. So the molecules of a solid, they are tightly packed or they are closely packed. So when we heat a solid or when the temperature rises, the molecules of solid, they keep vibrating in their own position. But since there is no intermolecular space in solids, they cannot move away from each other, but they just keep vibrating in their own positions because they gain some energy when the temperature rises. Next is the molecules of a liquid or a gas. The molecules of a liquid or a gas are loosely packed, so they can freely move away from each other. So as the temperature rises, the molecules first initially they start vibrating in their own position, then they move away from each other. So this movement is more in gas than in a liquid. This is because of the increased intermolecular space in gases than the liquids. And as we cannot see a molecule under a microscope, we cannot see the motion of the molecule also. But Brownian movement helps us to believe that the molecules are in motion. So next, let's learn about Brownian motion movement. Students, you know that air contains some small dust particles, and these dust particles, they cannot settle down easily, and they usually float in air. So that is what we call as suspended. They are said to be suspended in air, which means these particles, they just float in air instead of settling down. In fact, a small solid particle can be suspended in a fluid, for example a liquid or a gas. And a particle suspended in a liquid, it neither dissolves nor settle down. So a particle which is suspended in a liquid, it neither dissolve in it nor it settle down. So it neither get absorbed, or the particle is not soluble in that liquid, and nor the particles settle down in the liquid. So in 1827, the British botanist Robert Brown saw under a microscope that a pollen particle, so you all know what is pollen particle. So it is nothing but the pollen grain. So the pollen particles make a erratic movement. So erratic movement is what you can see in this figure 4.14, when suspended in water. So when the pollen particles are suspended in water, they make a erratic movement. Why does the pollen particle behave like this? It does because it goes on colliding with the water molecules, moving continually in all the directions. So why does the pollen particle behave like this is because they keep on colliding. Colliding means hitting something. Okay, so these pollen particles, they collide, they hit the water molecules, which continuously move in all the directions. So that is why the pollen particles make such an erratic movement when they are suspended in water. So the reason is because these pollen particles, they hit or they collide with the water molecules which are already in motion. So the similar erratic motion or zigzag motion is also seen in smoke particles which are suspended in air. In fact, this happens with all the solid particles which are suspended either in a liquid or a gas. So such an erratic movement of solid particles suspended in fluid like liquid and or air is called as Brownian movement. So children, what is Brownian movement? Brownian movement is the erratic movement of solid particles which are suspended in a liquid. So this erratic movement is due to the colliding of the solid particles with the molecules of the fluids, that is molecules of liquid or molecule of gases. Since this kind of erratic movement was first discovered by Robert Brown, a British botanist, this movement was named after him as Brownian movement. Next, action of heat on matter. So when any kind of matter is heated, it gradually undergoes changes in the following steps. So first is expansion, second one is change in state, and third one is chemical change. So let us see how these changes occur. So first one is expansion. So when we heat any kind of matter, expansion happens. So either it is a solid or a liquid or a gas, it expands on heating and it also contracts on cooling. When we heat any kind of matter, the molecules of the matter start vibrating in their own position. Then they try to move away from each other depending on the intermolecular space. So that is why matter expands on being heated. So next is change in state. So on heating, matter changes in state, which means a solid changes into a liquid into a gas on being heated. And the opposite changes occur when the matter is cooled sufficiently. So when heated, the molecules in a solid, they gain some energy and they start vibrating. The molecules of solid, they vibrate in their own position. So after vibrating, they try to overcome the intermolecular force of attraction and they try to move away from each other. So that is why a solid changes into a liquid. So this change in state from solid to liquid is known as melting. And the temperature at which a solid melt is called the melting point of the solid. And when we heat a liquid, again the molecules gain some energy and they start vibrating in their position and they overcome the intermolecular force of attraction and they start moving away from each other. So they form liquids, form gas when we heat them. So the change in state from liquid to gaseous state is called as vaporization or evaporation. So a liquid evaporates faster when we raise the temperature. When the temperature reaches a certain point, first the liquid will begin to boil. So you could see bubbles rising from a liquid when the temperature is raised or when we boil it. So the temperature at which a liquid boil is known as boiling point. So the temperature at which bubbles come throughout the bulk of the liquid is called as boiling point. So a liquid evaporates very fast at its boiling point. Again, when cooled, the molecules of the gas, they lose their energy, so they come back to their original position. The molecules, they come back to their original position. So that is why the gas changes back into liquid. So this change in state from gaseous to liquid is called as condensation. And when we further cool the liquid, the molecules of liquid, they become less energetic and they still move closer to each other. And the intermolecular force also will increase, and that is how the liquid becomes a solid. So the change in state from liquid to solid state is called as freezing. Lastly, we are going to learn about sublimation. So what is sublimation? We have already learned that some solids have the ability or tendency to sublime. Sublime means solids directly change into vapor without passing through the liquid stage or without passing through the melting stage. So this kind of conversion, so when some solids vaporize without melting, is called as sublimation. So when cooled, the vapors of such substances, they directly solidify. So the solid just obtained is called as sublimate. So by cooling the vapor, we get the solid. So this solid is called as sublimate. And the substances that can sublime are ammonium chloride, camphor, and naphthalene and iodine. So we studied that when any kind of matter is heated, it gradually undergoes some changes. So first is it expands. When we heat matter, it expands. Second is change in state happens when we heat matter. And third thing is chemical change takes place. So when we heat matter, many substances, they undergo a chemical change. So now let's discuss the example of burning of a candle. So what you have to do is weigh a candle, you light it and you watch for some time. So what you will see is the wax near the wick, it melts and part of it flows down and it solidifies. Okay, so there is solidification, there is a change in state. First it melts, then again it changes back to solid. Second is the part of the wax melt vaporizes. So when you observe the candle carefully, the part of the wax on top, it will first melt and then it will change into vapor and you could see its smoke coming out. And again, change in state is observed. Third thing, vapors catch fire and burn to form soot, carbon dioxide and water vapor. So again, vapors, they catch fire and they burn to form soot. Soot is the black thing which is formed. Carbon dioxide is produced and water vapor. So this is a chemical change that happens while burning a candle. And next, when the candle has burnt out, collect all the solid wax and weigh it. The solidified wax, it will weigh less than the original wax of the candle which you weighed earlier. Okay. So this is because some wax has burnt out. So that is why the solidified wax weigh less than the original wax. So next, do all substances undergo these three kind of changes on being heated? No, there are some substances which do not undergo all three kinds of changes like chemical change, change in state and expansion. So let's see some example. So first one, a piece of paper, when we heat it, it expands very little. A paper, it does not expand much, but you can observe a chemical change happening there. The paper will turn into black ash. So this is because the chemical change happening there, but there is no expansion there. No expansion, maybe very little expansion is there, but you cannot notice it. Very little expansion may take place, but no change in state happens there. Next, when we heat any substance or any element, it does not undergo a chemical change. So only in the presence of another element or another substance, it can undergo a chemical change. So these three kinds of changes that happen on heating is not common for all the substances. So from this, it's clear that all the substances do not undergo the three kinds of change on being heated. Students, to summarize, in today's session, we studied about Brownian movement and about the action of heat on matter. So now it's time for you to complete your assignment. Thank you, students. Have a nice day.